Okay, let's do another modelling style question here. Here's a set of data, and we need to come up with a rule that explains what the points are trying to do. So a rule that relates X and Y together. Step one, let's graph that and see what it looks like. Well, the points, and it looks like that. And we can see that it looks like the points are trying to make that sort of shape, sort of a hyperbola shape, sort of this format. There, our 1 over X style graphs. So if we convert the value of A and the value of B, we'll have a rule that explains what these points are trying to do. How do we come about doing that? If we can turn these curved line points into a straight line, the equation of the straight line will lead us where we need to go. First of all, let me just rewrite this for you, make it see it a little easier. How if I wrote it as A multiplied by 1 on X plus B? So we can see that it's exactly the same. It makes our life a little easier. So what I'm going to do, I'm now going, instead of plotting Y versus X, I'm going to go and find the values of 1 over X and plot them against Y. So if I plot 1 over X here, I'm going to end up with a straight line format. A multiplied by something to do with X plus B, it will be a straight line. So let's have a look. Alright, I've gone now and I've taken all these X values out and replaced with 1 on X. So 1 on 1, 1 on 2, 1 on 3, 1 on 4, etc. So if I now go and plot Y versus 1 on X, I'll end up with this shape. Now, if I go and plot each of these values, my 1 on X values, on my horizontal axis, we can see that 1 is my largest horizontal value, 0.17 is my smallest, and plot these values with the appropriate Y's, I get these points, which is almost a straight line. Now, in real life modelling, your points will never ever fit a really perfect 100% accurate model. Because we have natural variation, errors in measurement, the points will approximate towards whatever line they look like. In this case, it looks like a straight line, so we can assume that these points are trying to form a straight line. If I now use this straight line, work out its equation, so work out its gradient and where it cuts the y-axis, I'll be able to work out the gradient of this line will give me my A value over here, and where this line cuts the y-axis will give me my B value over here. So again, you can do that very easily manually. You can take any 2 points, that point there and that point there if you like, work out the gradient and you will have the A value. Generate the equation of the straight line, see where it cuts the y-axis, you will have this B value. Have a go at doing it manually, but like I said in the last video, you can also go and plot these points in your statistical editor and scatter plot them and generate a straight line that way. So I'd like you to have a go both ways. I'd like you to now work out the equation of this straight line and work backwards to its appropriate parabola. And then do it also on your calculator, see if you can get your calculator to come up to the same answer. And you should be looking for an answer something like this. So when you come to do this manually, you will have found that the gradient of this line here was 30.12 and it will cut the y-axis at 4.88. So we have everything we need over here now. So therefore, the original hyperbola its equation is going to be y is equal to, it's A over X, so we know that the A is the gradient of the line, 30.12 over X, plus B, which we worked out to be 4.88. Now that rule should very closely model these points, and you might like to go back and check. Go through and put X values of 1, 2, 3, 4, 5 and 6 into this rule and see if the rule spits out these appropriate values or very, very close to it. Hey, best of luck with that. Oh, by the way, there's question number 1 from the exercises. It's all to do with picking a model. So if you they'll give you some models to choose from. You just substitute the points into the given models and you'll be able to work out question number 1 without too much difficulty. But from 2 onwards, you'll be doing stuff like this from this video and from the last video. So good luck, and I'll see you in class.